Hello, everyone, and welcome to another edition of Space Snacks. Today I have Zoheyr Doctor, but the best part is it's Dr. Doctor. And so Dr. Proctor is interviewing Dr. Doctor today. Hi, how's
That's
it going?
perfect. Hey, good to see you, Dr. Proctor.
And so we actually met on Twitter. So this is our first time talking live together.
That's right.
And so I wanted to talk to you. It's been great following you on Twitter. The first thing that I want to do is kind of get some of your background. So let's take a moment and tell us, what do you do?
Yeah, I'm a postdoctoral scholar at the University of Oregon. I'm an astrophysicist. I work mostly with the LIGO and Virgo collaboration, and this collaboration works to detect and analyze these ripples in space-time called gravitational waves. And these gravitational waves come from distant black holes and neutron stars colliding with each other and near the speed of light. And when they do that, they ripple the fabric of space-time, and we measure that here on Earth. So that's kind of what I spend most of my day doing. And it's really exciting work, and it's been a field that's been blowing up in the last 5 years.
Yeah, so the first, you recently got your doctorate. So you recently became Dr. Doctor, correct?
That's right. Yeah, just back last summer. Yeah.
Congratulations. I know what kind of achievement that is.
Thank you. Yeah, I felt pretty good.
Yeah, once you become Dr. Doctor, nobody can take that away from you.
Yeah, that's right.
Now, the first actual detection of gravitational waves was in around 2015, correct?
Yeah, that's right. It was September of 2015.
Now, were you already working on your PhD at that time, studying gravitational waves?
Yeah, so I had, I was just a beginning graduate student. I was finishing up my first year. And, I was looking for people to advise me for my PhD research. And there was a professor at University of Chicago, Professor Dan Holtz, and his research about black holes sounded pretty cool to me. And, he worked on this experiment called LIGO, which is a huge experiment, but hadn't found anything. And I was like, maybe now's a good time to jump on this, and maybe there'll be a discovery while I'm a grad student. And within a few months, that first discovery happened, and I was, it was right out of the frying pan and into the fire for me.
That is fantastic. So have you always loved space? Is this something that you knew as a kid, that you wanted to become Dr. Doctor and do some research in space?
Well, I think as a kid, I was, a little bit more directed towards the medical profession, because, that's what people think of when, they hear doctor. Every school play I was in, I was always cast as the doctor, the medical doctor. So, that's kind of where I thought I was going to go at first. But once I got to the end of high school and college, I just found this incredible fascination with fundamental questions. How does the universe work? What's in the universe? Where are we in the universe? And once I started getting into that, I just couldn't put it down. That was what I had to keep studying and keep following up on. It was just so mesmerizing to me.
Now, were your parents like, wait, what? You're not going to become a medical doctor? You're going to become a PhD doctor?
Yeah, I think they weren't upset about that.
So when this is really out there. When I think of this, I think of Sheldon Cooper from The Big Bang Theory, right? And so when it comes to space exploration, do you also want to go and explore? Would you go to Mars, Moon, the International Space Station, or are you happy staying here on Earth?
I think right now I'm happy to stay here. At least I don't know if I have the physical capabilities of a lot of the astronauts who are really going up there. But in the future, when it's a normal person like me can hop on a spacecraft, I'm happy to do it. I'm excited to see what the future holds.
Where would you go when that time comes? As commercial space opens up, the idea of, and they just announced something yesterday about Tom Cruise shooting a movie on the International Space Station.
Oh, wow, I didn't even know that.
Yeah. So when you're thinking about space opening up, where would you want to go if you could go anywhere?
Well, I think, kind of in our local area of the solar system, I think Mars is, obviously exciting for a lot of reasons. maybe most importantly, the fact that we might be able to eventually, live there as a species. But one thing that's sort of been tantalizing in the last week or so is there was a proposal to just send a spacecraft to Planet 9, this purported other planet in the solar system. And so that kind of sounds exciting from sort of a science standpoint.
Yeah, that's really cool. And so, yeah, although Planet 9, now everybody's going to be like, but what wasn't Pluto Planet 9?
Yeah.
And so what would you, if you could go and explore Mars or the moon, if you're on Mars, what would you want to eat? Is there anything that if you could have your favorite meal, what would it be?
Well, I think my favorite snack has got to be the Jalapeno Popper, which is just a jalapeno with some cream cheese inside of, stuffed with cream cheese, and then it's deep fried in a batter. And so if I could just have an unlimited supply of those on Mars, I'd be all set.
I gotta ask, where is that coming from? Did you have one when you were a kid? Do you make them at home? What's going on here?
It was like my childhood snack after school. My mom would take me and my brother to the grocery store after school, and there was the hot deli section in the store, and my mom would get us jalapeno poppers from there, and that was like my favorite thing ever. And so, it's like one of those foods you like as a child, and you can't stop loving it even as an adult.
I love it. Jalapeno poppers on the moon or Mars, So do you like spicy? A little bit spicy?
Yeah, I like spicy.
We have jalapenos here in Phoenix, and so I haven't deep fried mine, but I definitely cut them and stuff them and then either grill it or bake it in the oven. Do you like to cook?
I do like to cook a little bit, but I'm not very good at it. I'm just learning. I'm getting better.
Have you mastered the jalapeno popper dish?
I haven't mastered it, although I have made it a couple times. Turned out pretty well both times. The second time, the jalapenos were really hot. And so that was both fun and painful.
Now I know that you're engaged. So yeah. Does your fiance like jalapeno poppers?
I'm trying to get her into them more. I've stocked up on a ton of them for the quarantine. So yeah, I'm slowly getting her into them.
So that's the survival food that you guys have. You're not hoarding toilet paper, you're hoarding jalapeno poppers.
Yeah, I think they're much more important than toilet paper.
Especially when it comes to like throwing a party. Thinking about your wedding and coming up, I'm sorry that this has thrown a monkey wrench in all of your plans. But do you like to throw space-themed parties?
Well, I don't know if I've had any space-themed parties specifically, but now that you say it, as soon as this whole lockdown thing ends, I'm definitely going to have multiple parties, and we'll make multiple of them space-themed. Oh,
that sounds good. And I know jalapeno poppers are going to be on the list. And definitely. So when you guys are together, what do you like to cook and eat as a couple?
So both of us, neither of us are that good at cooking. We, before we met each other, we were both big takeout fiends. We would, get takeout or delivery all the time. And now that we've been, trapped indoors together, we've been trying to figure out, what things can we cook. And so we have an Instant Pot. And so the Instant Pot has kind of been our go-to way to cook some really delicious food that doesn't require a lot of skill.
I love my Instant Pot. It's so awesome. And so those of you guys that are listening, it's like this magic device. Well, like you were saying, you put stuff in and it comes out delicious, especially meat.
Yeah.
And so what have you been experimenting with? What have you been throwing in your Instant Pot?
So we've made some like Indian curries. Those turn out really well in the Instant Pot. We've made like a casserole type of thing. I just made steel cut oats for breakfast earlier this week. That turned out really well. We made some brisket in there. That turned out awesome. So yeah, I feel like you can just do anything and it turns out really well and it comes out so fast too.
Yeah, you know what? I haven't tried Indian food yet. I went to, and it's funny because a lot of my guests that I've had on here, their favorite food has been Indian. And I went to India for the first time last year, and it was fantastic. And I've yet to try to take that on, but now hearing you in the Instant Pot sounds like that's the way to go.
Yeah, you can do it. And you know, there's all these pre-made Indian spice packets that have all of these spices that you could never pick up yourself one by one at the store. So you get one of those and you throw it in there with some meat and potatoes, and you're kind of good to go. It's so easy and turns out great.
That sounds fantastic. I'm definitely putting that on my must-try list. I want to get back to kind of the space and gravitational waves. When you were going through your undergrad and your master's, did your undergrad, was that in physics or astronomy?
Yeah, it was in physics, and I actually did a somewhat weird program where I did a dual degree between two colleges. So I kind of bounced back and forth between the two colleges over 5 years, and did my physics degree and then also electrical engineering.
Where
but
was
physics
that?
was so those were so my physics degree was at Vassar College in New York. And then if you wanted to do engineering and you were a Vassar student, you had to go to Dartmouth, which is in New Hampshire. And so I went to Dartmouth for a couple of years to do all the electrical engineering courses. So yeah, it was really fun.
That is so funny, because not close, but not that close to each other.
Yeah, so the program was, I spent 2 years at Vassar, and then I spent my junior year abroad at Dartmouth, and then came back for senior year to Vassar, graduated, and then went back for a 5th year at Dartmouth.
And so you said that was electrical engineering and physics, right?
Yeah.
And so then did you go on to your master's or straight into your PhD?
So I went into a physics PhD program, which has a master's portion at the beginning. And you can elect to get the degree if you want. So some of us chose to fill out the form and pay the money to get the degree. Others of us didn't bother. I didn't bother. Maybe in hindsight I should have, but
no. Well, I think that's the out where they say you've been a good student. Maybe you should take the master's and not continue. It gives you that kind of leeway to some extent. So did you know that gravitational waves back then, I imagine they were still kind of looking for this, this elusive thing. Did you, as an undergrad, was it even on your radar?
Yeah, it had been on my radar a bit because, in terms of experiments looking for black holes, this was kind of one of the most interesting ones. So it was kind of on my radar, but I graduated from college, or was in college around when the Higgs boson was discovered. So that was the thing that was really exciting to me. But by the time I got to grad school, I kind of saw what the particle physics machine was. It's thousands of people. It's a huge, huge operation. I was like, I think I want to do something, maybe more in the space realm and maybe a little bit downsized from that.
As a small kind of side note, I actually have been to CERN in Switzerland to present Meals for Mars, which is kind of ironic that I was at. Yeah, so I got to see just the whole behind the scenes particle accelerator. Very fascinating. Now, do you want to build instruments, because you have the electrical engineering background? Do you want to figure out what ways to detect or better detect these kinds of things in our universe? Or do you want to stay more on the theoretical side of just kind of the mathematics and the theory?
Yeah, I stay more on the theory and data analysis, mathematics sort of side. I love my colleagues who do the experiments, and I'm very jealous of their abilities. I have never been good at doing tabletop experiments or building things myself. So I leave that to them, and I do, the coding and building different models and things like that. Yeah, so it's a big team effort.
Yeah, it's really fascinating about the unraveling the mysteries of our universe and the multiple ways that we can do it. From the theory to figuring out how to actually build things to detect things that people will theorize exist, and figuring out how to do that is really fascinating. But I want to get back to food and
Okay.
dinner table and conversations. So
Sure.
when you get out of here and you're having a space-themed party, who would you want to invite and why? Who's going to be at the dinner table if you could have anybody?
Oh man, you asked me this in the form, and now I can't even remember who I had said I would.
It doesn't matter. What do you think? Who would you want to have?
Well, I think I'd want to have maybe my high school math teacher, who he was the one who got me really into math and calculus in my junior and senior years of high school. And I think that was, talking to him and learning from him was what sort of set me down the path of wanting to study physics. And he had come to my high school to teach, even though he had a PhD in math. He had spent his whole career teaching high schoolers to do well on the AP Calc test. And that really, I think, said a lot about who he was. Like, he really cared about the students, and he wasn't in it for himself or trying to climb some sort of ladder. He really cared about us. So yeah, I'd really like to have dinner with him. And unfortunately, he passed away a few years ago. So he's somebody who I just would like to have dinner with and sort of tell him, how much I appreciate him.
Oh, wow. It's so great to hear that. And it's a teacher appreciation week this week. So it's very appropriate. And as an educator, it's really nice when you hear that you've had an impact on students' lives, and especially where it completely changes their trajectory. And that's why education is so valuable. Have you done any teaching? Do you want to teach? Have you been able to teach as a doctorate student or as a postdoc?
Yeah, I've been able to teach a bit, and I think probably the favorite teaching thing that I did during grad school was I had the opportunity to teach a group of high schoolers in Chicago, about 20 or 25 of them. And every week I could teach them anything I wanted about science. So I decided that I would develop a whole year-long curriculum about music and electronics. So we spent the sort of first half of the semester. This was just like a Saturday 2-hour class. We did the first half was all about the theory of music. So learning about Fourier series and like amplitude and phase and all of that kind of stuff. And then in the second half, we started building little circuits and electronics and then using those to make musical instruments. So it was just really fun. It wasn't for credit or anything. And I think the students had a good time. And for me, it was like the best teaching experience because I developed the whole curriculum start to finish. Every week I built a whole lab myself and set it up for the students. And it was really fun. And, sometimes I failed epically, but that's just how it was.
That's part of the learning experience, but that sounds fantastic. Do you see yourself offering that again in the future, trying to offer that class again?
I'd like to do something similar to that in the future for sure. And, I eventually would like to teach maybe at the college level. So I think something like that would be a fun college class as well. Maybe bumped up the level a little bit, but I think something like that would be really enticing to students because everybody loves music and everybody's, in touch with electronics all day, every day. So
I think that sounds like a great class. I want to take that class. And at the community college, we actually have really interesting classes. I know there was a physics teacher who taught music through building a guitar. So you spent the whole, semester working on building your own personalized guitar and learning about physics that way. And I just think that's fantastic. When you're thinking of just with gravitational waves and all of this stuff, I mean, I know the void of space that it doesn't have a sound, but I guess what I'm saying is, what does that, can you go into more of the detection of gravitational waves and kind of what that looks like? Now, I brought a graphic up, and so I'm going to show it to you because I don't know if this has anything to do. I had to Google this, everybody, because this is definitely not my area. But if this means anything, and could you explain it?
Yeah, so I think if this is the image I think it is, which I think it, yeah. So this is, I think this is the most exciting thing that has happened in astronomy in the last few years. And so this, you see in this image, this galaxy, and in one portion of the galaxy, there's a little dot that's highlighted, and that dot is changing in brightness over time, which you see in the inset in the top right. And so that object you see there that's changing in brightness, we think was two neutron stars colliding with each other. So neutron stars are these essentially balls of mostly neutrons that are 1 to 2 times the mass of the sun. And when they collided with each other, they created this massive nuclear explosion in space. And they also rippled the fabric of space-time. So those of us in the LIGO collaboration, we saw that there was this signal from two neutron stars colliding from ripples in space-time. And we told all the astronomers, hey, you got to point your telescopes at this region of the sky and see if there's anything there that seems to be changing in brightness. And so I also work with a team of astronomers to try to point these telescopes. And so the telescope that we used was one of the first ones to see this changing brightness. So that was essentially telling us a ton of different stuff about nuclear physics, about the formation of heavy elements like gold and platinum, and also about the physics that goes into this extreme collision event.
Wow, that's pretty amazing. And that's got to be really exciting too, to be able to detect something and then working with such a big team and being like, yeah, point your telescopes here, let's see what's going on. And then the amount of data that you're getting back from that, just fantastic.
Yeah, so this was that one event was. Sorry, go ahead.
Oh no, I was just gonna say, and so when you have discoveries like this, celebration-wise, thinking about what you'd want to drink. Are you a wine person, a beer person? Do you like the hard liquor, spirits, mixed cocktails, coffee?
I'm a beer person, and I'm originally from Portland, Oregon, so I love IPAs. That's my go-to, for sure. Yeah.
Fantastic. And then, so you also mentioned that you and your fiance were takeout people. Do you have a certain type of takeout food that you like, being in Chicago right now? Or deep dish pizza?
I think me and my fiance may be deep dished out. I think we've probably eaten it too many times now. So our go-to order now is from this place called Lao Szechuan, which is a Chinese restaurant that's amazing, very, very spicy, and really, really good. So that's our go-to takeout order.
Oh man, that sounds amazing. And are you a snacker? Do you guys snack while especially since, okay, 99% of your job is on a computer, I imagine.
Mm-hmm.
And so you're sitting there, you got your laptop or well, I guess you'd need a really powerful computer. You got your computer. What are you snacking on?
When I'm working, if I could have that many jalapeno poppers, I totally would. When I'm working, my sort of creature comfort is sparkling water. So I'm always just drinking a sparkling water when I'm working. That's sort of like me in the zone.
Yeah. Is it flavored? Do you have a preference in flavors or any kind? Doesn't matter.
I think grapefruit is my favorite, but pretty much anything will work. Just something fizzy in my mouth. I just love that.
The grapefruit, yeah, that's really great. I like also the LaCroix. I think it's LaCroix that makes the grapefruit one. It's really good.
I love that one.
Thinking about your wedding, and I know you guys have been derailed a little bit there for having that, but have you talked about the menu and what you'd like to serve when that time comes, or what you think that you'd want to have?
Well, we're both of Indian heritage, so we definitely want to have some Indian food, maybe a little bit more modern American take on it. But we've just been set behind in all of our research because we don't even know what's possible for a wedding now. So
I know.
yeah, we
Makes it
haven't put as
hard.
much thought into it.
Now, is your fiance into space? Does she get what you do?
I think she gets it. I don't think she's into space as much as I am, but I don't know. I mean, most people I know aren't as into space as I am, but
I
no, I
imagine
think
that's
she thinks
the
it's
fun
interesting.
part because they gotta be like, explain it to me again. Do you ever just say, well, take Sheldon from the Big Bang Theory and apply it to gravitational waves or anything like that?
I don't know. I don't know about Sheldon specifically. I think most of the people I know aren't quite as unhinged as he is, I guess. But
especially because theoretically trying to explain gravitational waves and how you detect them. And so when we're talking about that, could you explain a little bit about that process? How do you detect gravitational waves?
yeah, we have a set of these devices called interferometers. So there's 3 of them that are online right now. 2 of the LIGO interferometers. There's one in Washington and one in Louisiana. And then there's an Italian one called Virgo from Europe. And so these interferometers are essentially these complex systems of lasers that go down, the laser beams go down these long arms that are perpendicular to each other. And those arms are each about a few kilometers long. And it's the timing of those laser beams going back and forth down these perpendicular arms that we can use to detect slight variations in space-time.
Wow. All right. That's really interesting. Now, I might have this wrong, but are they building a satellite system out in space? They're going to put one to be able to do something similar?
Yeah, so there's a proposal for one called LISA. It's actually more than a proposal. Europe is working on making this happen, and there's people all over the world who are kind of working together on it. I think it's probably not going to happen for the next 10 or so years. It's a big project, but it will be launched into space, and the hope is that this will detect really big black holes. With LIGO and Virgo, we're seeing black holes that are 10 to 50 times the mass of the sun, roughly. And with LISA, we're going to see things that are much, much bigger, potentially. So we'll find out.
And so, so we mentioned that 2 neutron stars colliding can create gravitational waves, but also black holes can create gravitational waves. Do 2 neutron stars colliding, do they create enough mass to generate a black hole? I don't know.
That's a really good question. That is I think one of the big questions that those of us who work on this have. We think that the 2 black holes that merged from that picture, the 2 neutron stars that merged in that little image you were showing, we think that those probably turned into a black hole at the end. They were probably, once they fused together, they were probably so massive that it just couldn't hold up against the power of gravity, and they collapsed to a black hole. But the truth is we don't know for sure. So it's going to take a lot more theoretical work, more observations of events like this. I think those together will give us a bigger picture. But it's like things in astronomy. You can't go there. You have to just do the best you can from here, and that's it.
That's really amazing and exciting. One thing I've noticed that a lot of people are like Jalapeno Poppers in the chat. So
yes.
Can you share with us your Jalapeno Popper recipe? I know you've made it a couple of times. What do you like to stuff it with? Do you do a specialty cream cheese, regular cheese? How do you bread it? What do you do to make a Jalapeno Popper?
Yeah, so the way that I do it, and I think this is different from the ones that people usually have, is I'll take the jalapeno popper, or the jalapeno the long way, and I'll cut it into little sections. So there's small little cylinders. And then I've stuffed the cylinder with cream cheese. And then bread it with...
You bread it with just regular breadcrumbs or anything? Do you have to put anything on it to make the breadcrumbs stick?
Yeah, I think you need some egg.
Okay.
So that will kind of get it to stick. You kind of have to double bread it a little bit. More breading, and is always good. And then,
you just
then I just fry it up.
Oh, wow. That sounds so good. Now I'm going to have to try that because I like the way you were talking about slicing. I haven't done that. I've usually cut up the top and then take out the seeds and then stuff my jalapeno. Thank you for coming on, Dr. Doctor. It has
Thank
been
you
so
so
good
much.
chatting with you.
Yeah, it was great to talk to you.
How can people follow you if they want to learn more about you and your research and the amazing discoveries that are happening out there in our universe?
Yeah, they can. People can follow me on Twitter. I'm actual Dr. Doctor. So it's like actual doctor, but the first doctor is just Dr. So you can find me there. That's probably the easiest way to see what kinds of things I'm working on. And of course, if you're interested more in gravitational waves, just Google LIGO-Virgo gravitational waves, and our collaboration has put together so many different graphics and other educational materials. So feel free to check those out. They're great.
Oh, that's fantastic. And you are a postdoc at the University of Oregon, Oregon State?
Yep, University of Oregon.
Okay, great. Yeah. Thanks everybody for tuning in, and have a great day. And let's go make some jalapeno poppers, huh? Sounds good.
Thanks, Diane.
Bye.
Bye.